Hi again, this is Ed, and we're going to talk about the Veeam API and Python in this part 6, and we're going to be talking about pandas. So this video, we're not going to go too much into the depth of pandas because it's a huge subject. I'm just going to give you the art of the possible with it and why I like to use it for data analysis. Um, I should mention this is just the absolute tip of the iceberg when it comes to Python and data analysis. Pandas is seen as the kind of the entry point. You know, usually for data pre-processing before doing other things like machine learning. But for me, my use, it's almost all I need really. I don't need to work out machine learning models and predictive analysis and things, at least at the moment. But certainly an easy way of manipulating large amounts of API or customer data, it's fantastic for. So we'll step through the it's pre-written Juniper notebook. At the top here, I've just got a bit of information about what you need to install. So you're going to need to install pandas and random word. Going down a bit, we can see that we've got the normal imports that we've had in the previous videos using user connect, and I've importing the pandas package using as PD, which is traditional. Now, a pandas data frame can be seen as essentially a virtual Excel table, and but more powerful than that in that you can pretty much do anything you want to do with it. So what I'm doing here is creating a random word list that I'm going to use to create a data frame from scratch. And so what I'm doing here is basically just using the package to create the instance of the class, getting some random words, and then stripping it down to just 10 words from that list because all I need to create the data frame. Here I'm using the random package to create some random sets of numbers. So between 2 and 25 and 3 and 50 and 10 of those. And then underneath here is the structure of creating a data frame. So I've got these essentially become the columns, and these are the index. And so the random words are the index for these columns. And when I print those out, you can see exactly as I mentioned before, that is a data frame. If I go down to the bottom here, we can see in this bit here on the data frame, if I press that, this is the great thing about VS Code, is it gives you access to this by going to, at the top, you'll see there's a variables button here. It's grayed out at the moment because I have it open, and it gives you access to these variables. And then you can have a look at the data frame. Now, it's not so useful at this size, but when you have maybe thousands, hundreds of thousands of lines of items, it can be useful to kind of have a quick look through things and to see how things are structured, or try to find an outlying item. So there are, like I keep on saying, there's a lot of different ways to cut and slice this data up, and I've just got a few examples here of what you can do with it. And I'm just showing you in the first example of a way of slicing values out of the data frame. So here we're using what's called an iLoc, and that allows me to grab the third and to the fifth item, and then you can select all the columns by using that colon just after the bracket. Going down a bit further, we can apply math functions onto these, and it's dead easy. So if, for example, if you wanted to add 100 or times everything by 100 in the data frame, you literally just go data frame times 100, and then you can assign that back to a new data frame. So that has now created a data frame 2, as you can see down here, with everything times 100. And this is why I usually say this is like cheat mode for data manipulation. Once you understand the syntax of it, makes this type of work really quick and easy. We can also do filtering based on values, so you can use operands in here. So in this example, this is the syntax for it. So you get the data frame name, you put the data frame name inside it, and he's basically saying where data frame 2 (1), so the first column, is over 1,000, and that will then deliver you the data frame that is over everything in (1) that's over 1,000. So you can see here that unfortunately everything in this example is actually over 1,000 in this case. So it would actually be better if I did this on (1) on df on df. Nope, no, it's actually called data frame. It's called, go back to that, get the data frame, put that there, put that there, hit go, and apparently nothing was over 1,000 in that one. So let's use a different number. Let's go with 10. So we'll go to 10, 10. And you can see everything now. Now it's over 10, and everything was over 10 again. Okay, let's go with, oh, go 5. Let's go with 5. That was wrong as well. Okay, but you get my point. This is what I'm saying here. Let's go with over 12. And over, I like 15. Let's go 15. There we go. You see, we are now filtering down the values using that statement. So going a bit further down, we have a thing called cumsum, so you can calculate cumulative value. So what I'm showing here is just how the syntax works with pandas. So you have the data frame name, open brackets, you select that column, and then you can then use the syntax there on another column, and then say what you want to do with it. So that could be mean, sum, cumsum, what is it we have here, and as you can see there, this is cumulative values for all of those columns, which makes it crazy easy to do. I should just mention as well that if I wanted to turn this data into an Excel sheet, just like right now, if I go df2.to Excel, and then I put in df2 data.excel, so hit enter, it's now created that Excel sheet. How crazy easy is that? So what we're going to do now is going to walk through the the backup file endpoint within Veeam. So I've done all the normal steps that we have in the last video, where we've created an instance of Easy Connect, we're connecting to the Enterprise Manager API, creating a function just to make, in case I was wanting to do multiple requests here, I can make it very easy by just calling this get data function now. And what I'm doing is I'm going for the query type equals backup file and the format entities. Now that bit's quite important because that saves a lot of API calls. You'll send the request to the endpoint. If you didn't do that, it will just come back with the list of the endpoints that have that data, which you could then use to get individual backup file information. But if you put format entities in that, it will bring back all the data for all the backup files. So it's just like a single call to get all the backup file data. And if I go up here, the backup file data, you'll see this is the data structure that we get back. And you can see that this entities is what I was talking about. So, and we can see the data structure here. So, and what we're actually going to be aiming for. So first to do that, you can see that's one big object. And inside that we have the entities. And inside that we have the backup files. And what we're aiming for is this data inside. So the backup file size, the data size, duplication, compression ratio, all this quite interesting information about each of the jobs. And we can clearly do something, be able to get some good information about this and be able to come up with some conclusions based on this information. So going down a bit, and we went through this in one of in the last video, where how you would walk through the data structure to get to the bit that you would want. And so, like we did before, I'm doing an initial call on keys, and that gives me back the entities as we've seen over here. And then we are going to go into entities, backup files, 0. So we're getting the first entry out of this particular backup file here. And we can see that we're basically at the level that we need when we want to get the data out of. And similarly, like we did in the last video, I'm doing a loop at that point to grab all that data out. Just to note that the backup job name is actually in this links list of objects or dictionaries, and it's under name there. So you'll see that I'm grabbing the name there. So that's how I'm getting the name out of this. And this is a good example of how playing around, looking for data is a good idea before jumping ahead too quickly with something, because you can find relevant information in the objects. It's worth getting it out of the program, get it into a file, look through it, play with the structure, see what's where, then figure out how you get to that data, and then create the new object based on it. So what we're going to do now is create a dictionary from that data that we've now restructured into a single list of dictionaries or array of objects. And the way you do it is you can imagine each of the objects here represents a row of data. So there's going to be backup size, data size, duplication, compression, etc. And then each instance is going to be a row in the table. So it's easy to show you what I mean by this. So the syntax for creating the data frame from a dictionary is as follows: pd.dataframe from dict, and then you put in what I've got here, filter bu. And if we do a head on that, so the head gives us back the first, I think, 5 items from the data frame. We can see that that object is now being transformed into tabular data. So we can now start doing operations on this data using pandas. So going down to the next line, we can see that this figure here is a bit, it's not easy to read. It's in bytes, so we want to see this in gigabytes, ideally. For me at least, because I haven't got a particularly large, backup environment. You may want to do it in terabytes, so you can just change this to 4. But for the sake, for this example, we're going to do it in gigabytes. So I've created a new column here, calling it backup size gigabytes, in the same data frame. And then going to the backup size and then dividing it by 1024 to the power of 3. And that takes us to gigabytes. And we go back down here, we can see that's now been added to the back of the data frame. How easy is that? I mean, I keep on saying this, but can you imagine trying to do that in Excel? Yes, you need to know the syntax of this, but again, once you've got that down, it makes your life a lot quicker. And this may be, so we've only got 80 something items in this particular data frame, but when you've got thousands or tens of thousands of lines, trying to do this kind of operation in Excel can be quite tiresome. So we're going to go down a bit further, and I'm just going to walk through what I've done here. So what I wanted to do was I wanted to get an idea of the compression level we were getting on a per job basis, and then rank that sort of highest to the lowest, so we can get some insights into what jobs are getting the high compression and what jobs are getting the low compression. So what we're doing here is we're doing a filter and basically filtering out everything from the main backup data frame here and putting it into a new data frame called VIB. So we're basically putting out all the incremental backup files. Now I'm just doing this there because you'll probably see a error sometimes come up that you're creating or doing transformations on a copy of a data frame, and the way you get around that is to create what's called a deep copy. Now I won't go into all of it. This is just I'm finding a good practice to avoid that error coming up because it gets annoying. It doesn't stop you doing anything. It's annoying. So once you've created the new data frame with just the incremental backups in there, we are going to do a quick bit of analysis across all those backups and to get an idea of what the average compression is across all the incremental backups. And it's 1.72. And you can also do .min and .max to get those two figures. So I've got min there at the moment, and if I go to max, I've got the maximum figure. Now, if we go down a bit further, we are going to create a compression percentage from the compression ratio. No, for other reasons. It's just I thought it looked cool, and I'm using a different method of doing that using the .loc method. So this is the last bit. So what I've done is I'm just demonstrating that you can chain on these function calls or these methods on the back of each other. So what I'm first doing is doing what's called a group by, and it's a bit like a pivot table. You can kind of see it here. So we're pivoting on the job name. So it's going to take everything that's got that job name, and we're going to filter down the output just to the compression ratio and the compression percentage, and we're going to use the mean value. So you can use mean, sum, max, min. You can also, there's other ways of showing them all in line, and that's using something called the .ag function with a curly braces. I won't show you that in this video. So we're going for mean, round. So we're going to round this down to 2, otherwise we get a long float. And then we're also going to do sort values. And we're going to sort the values on the compression ratio. and we're going to sort it to ascending false. So we get the highest at the top, and then it goes down to lowest at the bottom. You can see here, like, how great is that? You can do this in a very simple, chained way. I mean, you could do it, one after the other if you want to, but I'm a big fan of one-liners. So going down a bit further, we can see now that I have got the average compression ratio I'm getting across each job sorted by high to low. So if my mix sober, I'm getting 7.4, and the lowest I'm getting here is on my MacBook Air. But to be honest, I haven't backed that up in a few months, so probably why, I don't know. So anyway, that is a quick blast of Pandas. This was really kind of a primer to show you what was possible with this platform and what you could potentially do with it once you got the data in. There's so many things that we could potentially do with it. It's hard to give you, everything possible. But what I do encourage you to do is to try this out for yourself and see what useful business information you can pull out of it. Anyway, I'm going to leave that there. Thank you very much for watching, and I'll catch you in the next video.